Hello Year 11 and welcome to our second video here for our ninth topic, probability. In our first video we looked at the probability of simple events, and this time we're going to look at tables and tree diagrams. Now the reason that we're going to learn about tables and tree diagrams is so that we can examine the probability of multi-stage events. Okay, so this is where there's more than one part of this game or experiment. For example, if I flip 3 coins, right, there are 3 stages there, right? Whatever happens to the first coin, the second coin, and then the third coin. Now, if it's a 2-stage event, a table is the way to go, right? Because we can use the rows and the columns to represent the first and the second stage. So consider this. I've got 2 regular 6-sided dice. I roll them and I choose the bigger number. Okay, so that's a 2-stage event, the first dice and the first die and the second die. Right? Now I've got this table here, and up the top, right, the headings of the columns I'm going to make my first stage, and the sort of headings of the rows are going to be my second stage. And now, right, let's consider the first die was 1 and the second die was also 1, so I don't have any choice there. I'm going to choose a 1. Let's say the first number I rolled was a 2 and the second one was a 1, then I'm going to have a 2 there. I'm just going to sort of jump down here somewhere else. Let's say the first number was a 4 and the second number was a 3. Well, that would have to be a 4, but if my first number was a 2 and the second one was a 5, then it would be a 5. I'm going to go ahead now and fill out the rest of this table, and we'll have a look to see how it goes. So here we are with that table completed, and you can see that the size of my sample space is 36. My sample space has a 1, it has 3 2s, it has 5 3s, 7 4s, and so on. So that's the first part of this done. Secondly, the probability of a 5. Well, we know that the probability of an event is the number of outcomes divided by the size of the sample space. We've determined 6 by 6 gives us 36 as the size of the sample space. Now, how many 5s are there? We can count them up. We get 1, 2, 3, 4, 5, 6, 7, 8, 9. So let's see how we go here. Scroll up here, bring my pen down. Say probability 5. Equals the number of 5s, and that was, we said there were 9 of those, divided by the size of the sample space, which is 36, and I can simplify that down to 1/4. There we go, like that. So you can see there that a table makes that relatively straightforward. Okay, it's nice and compact. It doesn't take up too much room on our page, but it only works for a 2-stage event. Now, if I have perhaps something like a 3-stage or a 4-stage event, then my table stops working, right? My table only has 2 dimensions. It can only do the first and second stage. Now, we can use a tree diagram instead. And every time there's an extra stage, we fork each of the branches. Let's see how this goes. Now, I've got a bag here with 2 red balls and a green ball. I draw 1 ball out at random, have a look at it, and then put it back. I do that 3 times altogether. So now we want to draw a tree diagram to find the sample space. So what happens is, to begin with, at my first stage, there are 3 things that could happen. Right? Right, we draw it like this. It could be red, it could be red, or it could be green. Right? At the second stage, if the first ball was red, we've put it back in there, so I could still have a red, and a green. Right, and we'll join these up like this. Now, something to watch out for with these sorts of diagrams is that they get out of control pretty quick. that you really got to make a lot of space for them, and drawing them in pencil to begin with is not a bad idea because you might end up rubbing it out, which is what I'm going to do now. Hang on. Okay, so if we have a look there, we can see that, gee, it gets pretty complicated pretty fast. So the sample space is the list down here of all of those possible outcomes. So red, 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 green, red, 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 red. It's getting hard to say. Red, red, green, red, green, red, red, green, red, red, green, green, and so on. Now, if I count those up, I will see that there are 27 different outcomes in that sample space. Okay, there are 27 outcomes there. That's 3 times 3 times 3 again. Now, what is the probability of drawing a green ball at least once? Well, let's have a look. This has a green in it, so that's one of them. This one does. Both of these ones do, okay, because of that green there, and that one. This one, this one, this one, and those ones, because we've got the green there. Now, all of these ones will have a green in them because there's a green over here. So, all of those ones, count them up, and we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So, oops, scroll up here. So we're going to say, writing back in red, over here I'm going to say the probability of at least one green. It's not very concise, is it? The probability of at least one green is 19 out of 27. Right? 19 of those outcomes, 19 of those 27 outcomes have at least one green ball. Now, example 4 here, I've got 2 red balls and a green ball. One ball is drawn out at random but not replaced. How is this different? Another ball is drawn out and then the third. So, right, let's see how we go here. Have a look again. I'm just going to do this a bit quickly, hopefully. Now I'm going to say the first ball could be red, red, or green. Okay. Oops, hang on. Okay, so that's my first stage, but my second stage, right, if the first ball was red, then there's only one other red ball left in there. So the second one would have to be red or green, as simple as that. And the same thing here, red and green. Now, if the first ball is green, then they're both, the only other 2 balls remaining are red, right? So we'll draw up our tree there a bit, and let's see where we're at now. Now, if, right, there are 3 balls in the bag, and I've taken 2 out, I've taken the 2 red balls out, then in this case, there's no choice here. This one here must be green. Okay, if I've taken out a red and a green, this one must be red. 2 reds, that one must be green. A red and a green, that one must be red. Green and a red, that one will be red. And a green and a red, that one will be red. Now, often here, what we do is we will list the outcome at the end here. So I'm just going to write that in here as red, red, green, red, green, red, 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 green, red, green, red, green, red, red, and green, red, red. Okay, so now you can see that this sample space, this experiment, because we didn't replace the balls, this time I only have 6 possible outcomes. Now, the second part of this question is a bit curious. The probability of drawing consecutive red balls. So that means the first 2 are red or the second 2 are red. So, here's one, not that one. This one, not that one. This one, and this one. Grr. So, what's the probability of drawing consecutive red balls? We can see there, right, while it might not have been immediately apparent, I'm going to say the probability of red, right, 2 in a row equals 4 out of 6 equals 2 out of 3. Now there is another way of working this out, right? There's another way of considering this, and in this particular situation, if the second ball is red, then I'm going to get consecutive red balls. Okay, if the second ball is green, then that's going to separate the two reds. If the middle ball is red, then if the middle ball is red, then I'm going to get consecutive red balls in this situation. So we could narrow down our calculations here a little bit and go, well, what's the probability that the middle ball, that the second ball is red, and the probability that the second ball is red is 2 out of 3. Anyhow, that is how we use a table or a tree diagram to investigate the sample space and then calculate the probability of multi-stage events. If you've got any questions, of course, jot them down, think on them. Of course, you can always rewind and watch the video again if that's any help. But if you've got any questions, jot them down, ask me in class. I'll see you there.